Okay, so good morning, everybody. So I am Meluki Mohamed, and as planned today, I'm going to present what I did last year during my internship inside LabSec. And as you may guess from the title, it's about research projects in computer science, as computer scientists doing intelligent and interactive and autonomous systems, obviously here at Brest. I will start with a quick introduction, and after that I will move to cycle, and we will understand some basic terminologies that just to put you in the context of my internship. Then I will move to some results and conclude with ethics. So the research project aims basically to understand and evaluate cycle. And cycle, in fact, it is not an acronym, but it's just a name of a programming model for heterogeneous platforms. What does that mean? So we can just split this phrase in two. For programming models, you can think about it as just a programming way or a set of rules that define how we can program in an environment. And for heterogeneous platforms, so by platforms we mean a processing unit, like CPU in our computers, or a graphic card. So something that do processing and calculations. So in some cases, especially in supercomputing or in supercomputers, we need to put all of different architectures and different platforms in the same machine, so we can accelerate our algorithms. And hence the term heterogeneous, because we have multiple platforms with different architectures. And so you may wonder why this is important and why we care about it. In fact, these programming models are used to accelerate algorithms and to, in fact, doing some simulations and to get results in a short period of time. It is used especially in biology, physics, and also to train artificial intelligence algorithms. So, in fact, there exist we have already some programming models that they exist and we use it, such as CUDA. So CUDA is a programming model to program NVIDIA graphic cards. And we have OpenCL's Cocos and Raja. So, in fact, as we told, cycle is just a programming model. It's just a set of rules. So we need to have some implementers and some companies that make products from these results, from this model. So the first question that we asked in my internship, and the first thing that we did is state of the art. So we started to read papers and articles and all useful resources on the net to just answer to the question how many cycle implementations there are. Basically, we found that we have mainly 3 implementations, one offered from Heidelberg University in Germany, and other 2 implementations from Intel and Xilinx. So in this step, we need to check which one is the more efficient and the more practical that we can use in the industry. So we have installed the 3 implementations, and we have executed some programs that does some image processing on the 3 implementations, and we found that the Intel Intel implementation is the most mature. Uh, why? In fact, because it is not just efficient, but it proposes not just an implementation, but also an ecosystem that contains debuggers and libraries and some tools that are uh, very useful for developers. But in fact, we still have a problem because inside the research labs and companies, they already have their own code bases. So it's quite painful and difficult to rewrite the whole code base just to switch to another standard. So we need a tool that help us to migrate to cycle. So a tool that generates automatically cycle code from an existing code. We found that Intel has a tool called intercompatibility tool, which in fact gets in as input CUDA code, and it generates a cycle code. But we have found that yes, it does it automatically, but the intervention of the developer is mandatory just to check some parameters and values of some variables. Also, in fact, this migration tool works just with the CUDA. So if a research lab use another standards like OpenCL or Cocos, they have to rewrite their code base manually. So in fact, we use these technologies to accelerate algorithms, and we can use them, especially in physics, to push scientific boundaries forward. But we can easily misuse these technologies for example, to develop prohibited weapons and biological prohibited arms and biological weapons, so it can be easily misused. So that's all for me, and thank you for listening. If you have any question, just ask. I will be happy to answer.